So I'm going to review numbers 28, 29, 30, and 55 from the AP Calculus Midterm Review Worksheet. But before I do those, I'm going to review number 14 because I have a feeling a lot of people are going to attempt to do this question incorrectly. It's asking for us to use the definition of a derivative to calculate the derivative of this function right here. Now I have a feeling that a lot of people are going to say, oh, well, f prime of x equals derivative of x squared, use the power rule, is 2x, and derivative of a constant is 0, and the answer is 2x. And if you did something like this on a test, what would probably happen is you'd get a check mark and 0 points, because you didn't use the definition of derivative to calculate the derivative. So we have to remember the definition of derivative. We know that f prime of x is equal to the limit as h goes to 0 of the function evaluated at x plus h minus the function evaluated at x, all divided by h. And in the video description, I will try to link the video where I explain how we get this. So we're interested in the function here, x squared plus 2. So we know that f prime of x equals to the limit, as h goes to 0, of... So we have to evaluate this function at x plus h. So we have to plug that in right here for the x. X plus h, quantity. And then we have the squared right here. Minus, well, actually, we still have this 2 right here. So we can't forget about that. So this right here is now this. And then we have to subtract the function, which is x squared plus 2. And this is all going to be divided by h. And now we just have to do some algebraic manipulations to evaluate this limit. So the first thing I'm going to do is expand this square. So we know that x plus h quantity squared is going to give us x squared plus 2xh plus h squared. Then we still have plus 2. And I'm going to distribute this minus sign into the parentheses. It's going to give us minus x squared minus 2. And this is still going to be divided by h. And now we can simplify a little bit. We have x squared minus x squared. They cancel off. Plus 2 minus 2. They also cancel off. And we'll see that all we're left with is the limit, as h goes to 0, of 2xh plus h squared over h. Now, we can't plug the 0 in yet because we still have the h in the denominator. What we can do is factor an h out of both terms in the numerator. So this is going to be the limit as h goes to 0. I'm going to factor out the h in the numerator. Factor an h out of this term, I'll have 2x left. And factor an h out of this term, I'll just have 1h left. And this is going to still be divided by h. And now we can see how we can cancel off the h's, because h over h is just 1. And we know now that f prime of x equals the limit. I'm going to run out of room there. Equals the limit as h goes to 0 of 2x plus h. And in here we can just simply plug in the 0 for h. We know that f prime of x is equal to 2x plus 0, or just 2x. And this is how we use the definition of derivative to find the derivative of x squared plus 2. All right, next one we're going to do is number 28. This is a related rates problem. So we're looking for the rate at which the area is increasing. So if the area is A, the rate at which the area is increasing, that's going to be dA dt. Now you have to remember the formula for the area of a circle. The area of a circle is equal to pi times the square of the radius. And now, to find the dA dt that we're looking for, we have to go ahead and take d dt on both sides. Our goal in the end will be to have a number for dA dt. On the left side, derivative of a with respect to t is dA dt that we're looking for. And this is equal to, well, the pi right here is a constant multiple, so we keep that in the front. And we're taking d dt of r squared. First thing we got to do is bring the power to the front, make it the constant multiple. So we have the 2 in the front. Then we subtract 1 from the power, keeping the inside the same. So this is now r to the first power. We can't forget the chain rule. We have to multiply by the derivative of the inside function. Derivative of r with respect to t is going to be dr dt. Right, now we just have to find some values here. R, we're interested in the rate at which the area is increasing when the radius r is 10 inches. So we can plug that in. dA dt equals 2 times pi times 10. And the dr dt is the rate at which the radius is increasing. And we know that the radius of the circle is increasing at the rate of 5 inches per minute. So the dr dt is going to be 5. And if you work all this out, you will find out that dA dt equals 2 times 10 times 5 is 100. And we have the pi still. So we conclude that the area is increasing at a rate of 100 pi square inches per minute. Don't forget your units. Of course, if this were an FRQ question, you could stop right here. You don't have to simplify this to 100 pi and just put your units down at the end there and be done. And then for number 29, we're doing something pretty similar. So we know that air is being pumped into a spherical balloon at the rate of 28 cubic feet per minute. What that also means is that the volume of the balloon is increasing at a rate of 28 cubic feet per minute. Now we're looking at what rate the radius is changing when the radius is 3 feet. Notice this time we're looking for the radius, which is r, not the volume, v. So what rate is the radius changing? That means we're looking for dr dt. And this time they were so nice as to remind you of the formula for the volume of a sphere. So to find dr dt, we will still have to take d dt on both sides here. So if we do that, on the right side we will have dv dt. This will be equal to 4/3 pi is the constant multiple, so it stays the same. And we have to find the derivative with respect to t of r cubed. So we have to take this 3, bring it to the front as the constant multiple first. And then we keep the inside the same and subtract 1 from the power. That's just a power rule, so it becomes an r squared. But then by the chain rule, we have to remember to multiply by the derivative of the inside function. Derivative of r with respect to t is the dr dt that we are looking for. And now we just have to use our values to figure out what dr dt is. So dv dt, that's the rate at which the volume is changing, which is this right here, 28 cubic feet per minute. So we know that dv dt is 28. 3 over 3, they cancel off, and we are left with 4 pi r squared. Well, we're interested at when the radius is 3 feet, so we have to plug in 3 right here. So 3 squared, that's like multiplying by 9. And then we still have the dr dt right here. So now we just have to clean this up a little bit. We know that 28 equals 36 pi times dr dt. And then divide both sides by 36 pi, and we find out that dr dt, well, equals 28 pi over 36. You could leave your answer like that on an FRQ, but I'm going to go ahead and pull out the factor of 4, reduce this to 7 pi over 9. cubic feet per minute. And let's take a look at number 30 now. Please note that this was, in fact, a mistake on the study guide. This is supposed to be x squared here, negative x squared, not just negative x. All right, so we know that a point moves along the curve, well, this curve, so that the y value is decreasing at a rate of 3 units per second. Keep in mind it says decreasing here. We'll have to remember that in a second. So we're looking for the instantaneous rate of change of x with respect to time. So in other words, we're looking for dx dt. So another related rates problem here. We're going to take a look at this. We're going to take d dt on both sides. So we'll take d dt over here and d dt over here. All right, d dt of y is going to be dy dt. And this is equal to, I have this 10 in the denominator here. That's like a constant multiple of 1/10. That stays the same. And then we just have to take the derivative of the numerator. So d dt of negative x squared is going to give us negative 2x. And then using the chain rule multiplied by the derivative of the inside function, we find the dx dt that we're looking for, plus 4 times the derivative of x with respect to t. Let me keep this in the same color here. And then the minus 3 right here, derivative of minus 3 is just 0 because it's a constant term. And now we just have to use our values for dy dt and for x in order to figure out what the dx dt that we're looking for is. So dy dt is the rate of change as y, and here's where you have to be careful. So we know the y value is decreasing at the rate of 3 units per second. So in other words, it's getting smaller by 3 units every second. So that means we're looking at a negative 3 for the dy dt. This is still going to be equal to 1/10 times negative 2 times, we're interested at this x value right here, x equals 5, times dx dt plus 4 dx dt. Now we just have to do a little bit of cleaning up. So we know that negative 3 equals to 1/10 times, well, here we have this negative 10 dx dt plus 4 dx dt is going to give us minus 6 dx dt. And to simplify things a little more, I'm going to divide both sides of this equation right here by negative 6. These will cancel off. And on the left side, negative 3 divided by negative 6 is positive 1/2 equals 1/10 dx dt. And then we just multiply both sides by 10, and we find that dx dt is equal to 5. And don't forget the units per second. And we have one more. This one's a word problem. Now, please note that I'm going to assume that this would be a calculator problem on the test because you are dealing with some pretty nasty numbers for calculation here. So basically, if the manufacturer determines that X employees on a certain production line will produce Y units per month, to obtain maximum monthly production, we want to find dy dx, and we want to set that equal to 0 using the first derivative test. So let me write the function again because they spread it over 2 lines. So we know that y equals 75 x squared minus 0.2 x to the 4th. And I'm going to take d dx on both sides so that we can find the dy dx. On the left side, derivative of y with respect to x is dy dx. this is equal to, so we use the power rule, bring the 2 to the front. This becomes 150, x to the first power now, minus, and then here we bring the 4 to the front. It's going to be 0.8 x cubed. And we're interested at when dy dx equals 0. So we want to set 150x minus, perhaps I will put these in descending order of the degree, minus 0.8x cubed plus 150x equals 0. So we have a cubic function set equal to 0. We have no linear term. What that means is that one of our solutions for x is going to be x equals 0. To find the other solutions of this equation here, I can divide both sides by x, because I know I'm looking for solutions where x is not 0, so I can legitimately divide both sides by x. So I'm going to divide this side by x, divide this side by x. So it's going to give me negative 0.8x squared now, plus 150 x to the 0th, which is like 1, x's cancel out, equals 0. Tells me that negative 0.8x squared plus 150 equals 0. And, well, I wrote that down again. What I wanted to do was subtract 150 from both sides. So basically that's going to tell us that negative 0.8x squared is equal to negative 150. Divide both sides by negative 0.8. We know x squared equals 150 over 0.8 because the negatives cancel. And then we have to take the square root on both sides, so we know that x equals plus or minus square root of 150 over 0.8. And this is why I say we will need the calculator for this problem. So let me bring up the calculator here. So we're looking at 150 divided by 0.8 equals 187.5. And then we can take the square root of that, so it's about 13.693. 13.693 and negative 13.693. Now the question is, let me bring this up on Google Chrome here. Oh, I can't bring it up on Google Chrome right now. Well, the question, they asked us for number of employees. Now, if we have 0 employees, that's not going to make it very effective. So we're not interested in that answer. Can't have a negative number of employees. So all we have left is this 13.693. And we have to round that to the nearest employee. So basically, our final answer is 14 employees. Don't forget your units here, employees. So I hope this helped. On the exam, make sure that you are reading the questions again after you get done with them to make sure that you've answered the question that was asked, and make sure that you included units when necessary.